Example, deep oil submersible pump. This example came from one of the pump that is advertised in Amazon.com. You can click on this link and see this pump, and all these descriptions are taken from that website. So this is a deep oil submersible pump. It says that the pump flow characteristics, it says that it produces 11.5 gallon per minute at a feet of 103. So that's the best at best performance. So if we convert that pressure, it says convert the pressure head to feet of water. P equals gamma H. If you want to take one thing from this clutch, this is the formula you should be taking with you. um, so water gamma is the 62.4 pound per feet cube. If you fill a 1 feet cube box with water, it's gonna weigh 62.4 pound, and then 103 feet of water, so that's gonna be I didn't calculate that part. And then we can convert this to feet to in inch cube. So I know that 1 foot is 12 inch, and then whole square that, because this feet and feet cube, I'll have feet square at the denominator, so to cancel that I need feet square in the numerator, and then this is just the equivalence of that. So if you calculate this, it's going to be 44.6 psi, and then I calculate the peak power. So that is the peak performance of the pump. It produces 103 feet of head at 11.5 gallon per minute. So we know that power is if pressure is in psi, flow rate is in gallon per minute, then divide by 1714 will give you the value in horsepower. So let's plug all this number. I got 44.6 psi times 11.5 gallon per minute, divide by 1714. I have calculated that 0.3 horsepower. So the loss would be, it says that it's a half horsepower pump. So the power is rated at 0.5 horsepower minus that delivery, that is the loss, 0.2 horsepower. Now what is the primary source of loss in this case? Is the loss due to the fluid friction in the pipe. So the loss, just write the fluid friction on the pipe wall. So you have 133 feet of pipe. That's a long pipe, so that is the main loss in this case, the fluid friction. Calculate the efficiency. Efficiency is power out by power in. So we calculated power out is 0.3 horsepower by power in was 0.5, so that is 60%. And then assume the volumetric efficiency is 90%. If the maximum flow is delivered is 20 gallon per minute. This also came from the pump characteristics, so you can check that in Amazon.com, the link that I posted. So the volumetric efficiency eta V is the actual flow rate that will be available from the pump, and in theory how much should it produce. So that 0.9 is equal to 20 gallon per minute divided by QTH. So the theoretical flow we get, I calculated that 22.2 gallon per minute. Now it says here if the pump speed is 3450, this is also came from the pump characteristics data from the Amazon.com website. Calculate the size of the pump. So basically what it is asking is what's the volumetric displacement. We know that theoretical flow rate can be determined by this equation. So then this is calculated 22.2 gallon per minute is volumetric displacement times the RPM. So I got I actually directly converted that to gallon per minute. So this gallon per minute, we can multiply this by 230 1 inch cube is 1 gallon, so that gallon cancel, so I directly got the VD is 1.49 inch cube. So that is the volumetric displacement of the pump. This question is asking that that flow that it develops, that 20 gallon per minute, if it uses a 4-stage pump, typically to produce high pressure, deep well pump uses multiple stages of impeller. So you have like one impeller there, one impeller there, and then one impeller there. So multiple stages of impeller. Basically, this adds the pressure, not the flow. So the flow produces 20 gallon per minute from one impeller. So the question is, does it come from all 4? No, just one impeller produce the flow, send it to the other, create some pressure, and then send it to the other impeller, create some more pressure. So these multiple stages of impeller only create pressure, not the flow. So therefore it will come from just one impeller. I think that was this question.